Welcome to this weekend update. It will just be a short video to let you know a few things. A viewer of the channel contacted me a couple of weeks ago to show me his Tindie shop where he sells small electronic modules and asked me if I would like to take a look at his modules. He focuses on battery charging modules and wanted to send me a few battery charging modules for review. But then I spotted an interesting module in his shop and I thought I'd tell you a few things about this one. It was this itty tiny fuse reset circuit that caught my eye, and that's something I needed a few years ago when I first started with microcontrollers, but I never actually built one. So years ago, when I was programming microcontrollers in C, or I was learning to program them, I was using AVR microcontrollers, and I had to learn how to set the various registers, how to configure the microcontroller by setting the appropriate fuse bits, for example, for selecting an external crystal or configuring various other functions. Some of those fuse bits control, for example, if the serial programming interface is enabled or disabled, or they control if the reset pin is just a simple I/O. So if at any point you would accidentally disable the programming interface or the reset pin by setting the wrong fuse bits, you would lock yourself out, being unable to further program that chip. And so I bricked a few microcontrollers by doing that. It was of course part of the learning process, and I'm sure many of you went through the same stuff at some point in the past. But there is a way to recover those parts. There is something called high voltage programming, where you have 12 volts applied to the reset pin, and with the proper sequence sent to the chip, it would reset the fuse bits to the default state. And that is what Christos, the owner of the Tindie shop and the viewer of the channel, built. Here is the module he sent me. He mentions he didn't exactly meant to sell these, but he ordered 10 PCBs, and as he had a few more PCBs, he also built those and listed them in the Tindie shop. As far as I know, all AVR microcontrollers support the high voltage programming interface, and there are two different interfaces depending on the device pin count. For a small pin count, like the 80 tiny devices, there is a serial interface, while for the higher pin count devices, a parallel interface is used. There are even programmers and debuggers that support that and have built-in circuitry for the high voltage interface. Years ago there was the AVR Dragon and the STK500, but those were way more expensive than the basic AVR programmer, so not everyone had access to them. So this shield basically has an Atmega 8 running some code and a boost converter. We can see the inductor and the small chip here that boosts the 5 volts coming through this micro USB up to 12 volts, and that is applied with a transistor to the reset pin in a certain sequence. When you press the start button, the Atmega just runs that sequence, applies the 12 volts, and then it will send some required commands to the microcontroller over that programming interface to reset the fuses to their default state. So if you need some battery charging devices, you might want to check out Christos' page on Tindie. He tells me he is also working on a new module that will have UPS functionality, which should be great for keeping the juice flowing for something like an Arduino or any project you're working on. This weekend I'm also hoping to get this BL touch sensor wired and working with my 3D printer. I have already done the wire harness, is this blue one, but I still have to connect it to my CR10 3D printer because my print bed is pretty much a mess, and having this sensor to measure and compensate for the warping should improve the quality of my prints, and it should be more reliable than the inductive or capacitive sensors I've tested in the past. I'm also dealing with some adhesion problems when printing the larger parts, and I don't know how to fix that. I'm using the standard glass bed that comes with the CR10, and it has worked great for small parts, but when I start printing parts which are larger than 5 or 6 centimeters in length, the corners just start to lift after the first layers have been printed and they cool down. So I'm not sure what's happening. I've seen many people using those IKEA mirrors, and I would like to give them a try, although I'm not sure how that's going to change anything because it's still glass. But I don't know, maybe it has a different type of surface that provides better adhesion. We'll see. But I'm also seeing people getting good results without using any hairspray or glue, just with the default bed glass. So I'm not sure how they're doing it, but I would like to learn how. What settings should I adjust in my slicer profile to maybe improve the adhesion. I think I'm currently printing with the default profile for the CR10 3D printer in Cura, which is for PLA in my case, 200 degrees nozzle temperature and 60 degrees bed temperature. So if you know anything about that, please let me know. That was all for this weekend. Thank you for watching, and I'll see you next week.